everybody, and welcome. This is Karen Fox with the Office of Communications at NASA. Thanks so much for joining us to talk to some of our experts about the completion of our Sunshield deployment today. We have 4 people in the room with me, all of whom are taking a break from their jobs at the Mission Control Room today. So we will be getting them back as quickly as we can after about half an hour. We will focus on your questions today with just a little bit of a presentation at the beginning. The people I have in the room are James Cooper, who is the Sunshield Manager for Webb at NASA Goddard. We have Alfonso Stewart, who is the Deployment System Engineer at NASA Goddard. We have Jim Flynn, the Director of Vehicle Engineering for Webb at Northrop Grumman, and Hillary Stock, the Sunshield Deployment Specialist at Northrop Grumman. So again, thank you all for being here. We will start quickly with some comments from James Cooper, who is going to walk us through what was accomplished today, as a little bit of a nod to the last few days, and then we'll open up for questions.
Right. Good afternoon. So today was a big day, obviously, for us. We finished tensioning the last 2 layers of the Sunshield, so that completes the Sunshield deployment steps. We've gone through over the past number of days all the major structure deployments, and yesterday we started tensioning and got through 3 layers, which was actually a little more than what we had planned to get done yesterday, so that was great and enables us to take a few additional steps this afternoon. But yes, great feeling to be done with this phase, and definitely take a big deep breath after that before we move on to the mirror deployments.
Well, thank you so much. And as I said, we will be focusing on Q&A today. To register for a question, go ahead and type in *1, and I'm going to open it up to our operator to share information on how this will work today.
Thank you. Again, if you would like to ask a question, please press *1 to join the queue. If you would like to withdraw your request, press *2. Again, that's *1 to ask a question. And our first question comes from Marina Corin. You may go ahead with the Atlantic.
Hi, everyone. Congrats on the deployment. 2 quick questions. First question, how did the Sunshield tensioning compare to your predictions on the ground? Were there any snags, and were there any surprises? I think this is maybe a question for James and Alfonso. And then a second question for Jim and Hillary. A few years ago at Northrop Grumman, there was a pretty stressful situation with, fasteners coming loose on the Sunshield and scattering. And if you could think back to that moment and then today, what does it mean for you to actually have this Sunshield deployment completed after some of the problems that you experienced on the ground? Thank you.
All right, this is James. I'll start with your first part of your question. So the predictions were amazingly good, I'll say, and a nod to Hillary actually for a lot of that because based off of the ground testing data from all of the tests out at Northrop, we had very detailed predictions of motor currents and how long it would be when we latched. And yeah, I think from my perspective, and talking, and Alfonso's nodding his head too, we were extremely happy with how well things matched up to that. So I would say the tensioning phase especially went better than we could have hoped.
Yeah, absolutely. Just one thing though, I want to just point out the obvious. This is the first time we deployed this system in a zero-G. And to say that we did it for the first time and it was very successful, as predicted, is a really good test, to the work Hillary and the rest of the team did. So it's very good. First time, and we nailed it. So that was a good thing. What was your?
Yeah. So this is Jim. I guess with respect to the issues that we worked through along the way, the fasteners being one of them, it was really the fact that the Sunshield's an integrated system, and we learned things as we were putting it together and testing it, and that was really what we did expect. So there was going to be some learning moments along the way. And with that and the other things along the way, I was always just very proud about how quickly the team was able to work through these problems, come up with solutions, keep the hardware moving and the testing and learning along the way and improving the product along the way. And, you know, it's a great feeling to be at this point, knowing that we had all those lessons along the way and the team always responded, and to get to this point and be successful is just a great feeling, I believe, for everybody, you know, over the years in terms of developing this product through design, build, test, and to get to this point is great.
All right, I think we can take the next question.
Our next question is from Bill Harwood with CBS News. You may go ahead.
Hey, thanks. Yeah, and if you guys could please identify yourselves when you talk, it'd really help those of us who aren't familiar with your voices. You've kind of alluded to this, but how does the telemetry tell you that each layer is not fully taut, but that all the seams are intact, no layers are touching at any point? I mean, obviously you know that, but I'm just curious how you're able to follow along. The question I get most often is, you know, there aren't any cameras, so how do you absolutely confirm everything? And secondly, what's the mood like? I mean, this is, you know, we've all been talking about the Sunshade for years, months, you know, about what a challenge it is. I mean, I'm just kind of curious if there's any way to describe what you guys are feeling right now. Thanks.
Well, this is Hillary Stock. I'm a deployment specialist, and I can tell you the mood was hard to describe. It was a wonderful moment. There was a lot of joy, a lot of relief, but that was really because all of our telemetry was showing us everything was nominal. We've treasured this from 2016 when we first built these tensioning units, and we've been tracking it all the way through. And what we're seeing is really this heartbeat of this mechanism. And this mechanism is very intricate, it's very complex. But because of that, we're able to glean so much of the hardware position, the hardware resistance, all of that from the motor telemetry. So we feel very, very good looking at these signatures, seeing these drops in current and understanding that that's related to a layer latch, to a correct position, and everything lined up today.
Yeah, this is James. Again, if I could just add to that, I think, you know, to the first part of your question, that we and it goes back to the prior question about how well it matched predictions. And so we knew on the ground, you know, how many revolutions of the motor to expect, what distance of mid-boom stem deployer to expect, what motor current to expect for a latch out of every layer. And so each one of those had been predicted, had been tracked through the ground testing, had been adjusted for what we thought the differences would be in 0G and at different temperatures. And so tracking all of those parameters give us that good indication that it went as far as we thought it would, it pulled as hard as we thought it would, therefore it's in the right place. So that's kind of the way we make those connections without any images.
And I'll just say to your point, Bill Harwood, just so you know, it's a little confusing. We have a James Cooper and a Jim Flynn. So if you hear the identified as James, that's James Cooper, and the identification as Jim is Jim Flynn. And with that, I think we're ready for the next question.
Our next question is from Irene Klotz with Aviation Week. You may go ahead.
Thank you very much. Good afternoon. I have two questions. I'm not sure who's best to answer. The first is, could you give us an idea, please, of how the temperature, the rate of the temperature drop? I know it's going to be a while before there's a 600-degree differential between the outermost and innermost layers, but how quickly does that happen? Maybe if you have some specifics, like what you expect the temperature differences to be like within a day or a week or 2 weeks. And then also, I just wanted to verify my understanding is correct that these motors are now, they're extraneous. They're never going to be used again. And if that's right, and do you disconnect power from them, or what happens with that? Thanks.
I can respond to the motor question really quick. That's an easy one. That is correct that we will never use these motors again. So the drive electronics units will no longer be energizing them. So we're not disconnecting anything. It's just not going to turn them back on because they have done their job, served their purpose, and now they're along for the ride.
Well, let's see. There's a thermal question here in terms of the membranes themselves. So the membranes are really, very low mass, right? There's not a lot of, what we call thermal inertia. So they're going to cool down fairly quickly to their temperatures. It's really the structures that we're trying to cool, the telescope structures that are going to take, days, weeks, or longer to get down to their temperatures. But the Sunshield itself and the membranes itself, as soon as that layer, the bottom layer is hitting the sun, it's getting to that hotter temperature. Now that layer 5 is separated from the other layers, it's going to cool down fairly quickly as well. So the membranes are going to hit their temperatures in a fairly rapid fashion, but it's the remaining structure that's got the thermal mass that's going to take some amount of time to cool down. I don't know the exact times, but that's maybe the way to look at the problem. So, sorry, and again, this is Jim Flynn.
Thanks. And was that Bill Ochsner who addressed the team after deployment?
Bill Oakes. Bill Oakes,
yeah.
the NASA program manager.
Okay, thanks.
Right. And our next question is Mike Wall with Space.com. You may go ahead.
Thank you all, and congratulations on this big milestone. Is it safe? So there was just one little tiny hiccup with the Sunshield covers. Maybe it wasn't like you guys weren't sure if they'd rolled back all the way, but it turns out that they had. Was that the only really issue that you guys had to work during the deployment of the Sunshield and the tensioning, or were there some other little things? It just seemed like it was super smooth all the way through. But if you had any kind of obstacles, I'd be keen to hear what those were. Thanks.
Honestly, it went incredibly smoothly. I feel like we've all kind of been shocked that there's been no drama. It's been very smooth. And we did have a little moment there where we were looking at the covers, making sure that they were in a configuration that we could expect. But we took our time, were cautious, went through all the requisite steps, eventually got our confirmation through the motor telemetry that we deployed. And from there, it's been smooth sailing.
Yeah, this is James. I just add that I think it really was. I certainly wouldn't say it was boring. We've all been joking, I think, for a long time that we wanted to be bored out of our minds for 2 weeks here because that would mean everything was going as planned. But though we did spend a lot of time with coming up with contingency plans and procedures, and okay, if this happens, we'll back up and try again, or we'll push harder, or what the next appropriate step would be. And we didn't have to do any of that other than, as you mentioned, the cover telemetry not fully indicating that the entire length of the cover had rolled out of the way, but we now have good evidence that it did.
This is Alfonso. I just want to add something to that. The question about, what you call a hiccup and, was that an issue? But the way, we've been rehearsing the whole process for several rehearsals, many years probably. In each of the telemetry, I believe, we have multiple ways of confirming it. So if one telemetry doesn't work, we have indirect information that can give us some assessment about it. In addition to, as Hillary said, there's a certain signature that if the system is working properly, this is the signature we expect. So even though we may have a telemetry that's telling us something on an unexpected reading, we have data, additional data that can confirm that. And so in this case, yes, we saw something that we weren't expecting, but we also have other telemetry that allowed us to continue, and the result of that is a successful deployment. So all of these deployments, we have multiple ways of assessing where they are and what they're doing.
Thank you.
You're welcome.
And our next question is from Eric Berger with ARS Technica. You may go ahead.
Hi, congratulations, everyone. What a great day. I'm wondering, sort of, as a layperson out there, how should we feel about the progress made so far? Obviously, you've got 5.5 months to go. It's only been, a couple of weeks since launch. But, is the most difficult part behind us? And, should we now feel pretty confident that this is all going to work? Because I'm not sure I felt that way 2 weeks ago. Thank you.
James, I'll start giving it a shot. I mean, I think everybody might have a slightly different opinion on which part is the hardest, right? You ask the telescope people, and they probably have their worries. Me being Sunshield centric, I'll say, yeah, the part I was most worried about is behind us now. But on a more serious note, I think that the Sunshield deployment certainly was the most complex in terms of moving parts having to all work in harmony, right, and systems that interplayed with each other, structures and mechanisms and cables and membranes that are non-deterministic, right? The stuff that's left from a deployment's point of view is more conventional hinges and motors and things like that I think we can feel maybe less worried about the complexity of them. However, they're really, really cold, and getting the telescope, the optics focused and everything, I'm sure if you had an OTE engineer here, they would have their worries about the complexities of getting the mirror tuned. So hopefully that helps to some degree. From a mechanical complexity point of view, I would say yes, the Sunshield part was the toughest.
I was asked this question several months ago, what's the thing that I was most worried about? And the first thing I said was the solar array. And the reason why I said that, because without power, you can't really do much. You can't get creative, you can't reverse, you can't do anything. So my thing was, you got to get power first, the solar array, which obviously it worked. And the second thing for me was the Sunshield. And the reason why I said the Sunshield, because I know from all the inspections and seeing all the hundreds and hundreds of parts, to say that all of these things are going to work, and work as expected, it's like, wow. So, but for me, though, without power, we can't do much, so you got to get the solar array out. And I'm past that point, so I'm okay. Whatever we have left, I'm pretty sure we can figure out what to do with it.
And our next question is from Marcia Smith with SpacePolicyOnline.com. You may go ahead.
Thanks so much. I'm wondering about the life-limiting factors for the telescope overall, and everyone's talked about the fuel as one of those, and I guess coolant for MIRI is another one. And I'm wondering, is the Sunshield a life-limiting factor as well? Is there X number of micrometeorite hits that you can tolerate, and if you exceed that, it becomes less effective or ineffective? What could possibly happen to the Sunshield now that it's deployed that could make it ineffective?
Yeah, I mean, you're exactly right. So early on in the development, we actually did micrometeorite testing where we took 5 membranes at temperature at one of the universities, accelerated particles to get a sense of, how much damage they would do. And the good thing was that they pierce through the membrane and basically, pierce into smaller holes, but they don't cause it to kind of, shred, and become much more detrimental. So it was very valuable in understanding the performance on orbit. So by taking that L2 orbit, we basically were able to design the Sunshield for what's called a transmission requirement for about 10 years of life, based off of a predicted, micrometeorite environment. So it is a limiting factor in that, the micrometeors will slowly degrade the performance of the Sunshield over time, and basically we, designed it to 2 times our life requirement to about 10, 11 years. And we certainly need to talk to one of the optics guys about whether or not it's a graceful degradation, which is what I probably believe it would be, rather than just kind of falling off a cliff. So that probably is, you're right. The optical properties will change a little bit with radiation. We found through testing and get warmer, but once again, designed for 11 years. So over time, that thermal efficiency of the Sunshield will degrade, but we should see that happen, very gracefully over the life of the program.
So when the people talk about the fuel lasting longer than 10 years, people shouldn't get too excited yet because the Sunshield may not last longer than that?
Well, let's see. What I think I'm trying to say here is that we've designed the system to, well exceed the mission requirements by a factor of 2, and it's just some very conservative, requirements that we were given, and we've tested it to show that it degrades gracefully. So, I can't say across the entire observatory what's the thing that's the most limiting. The question was from a Sunshield point of view, what it is, and there's a lot of margin to our requirements to meet the mission requirements, with factors included. So I'm not sure if that helps clarify that question or not.
Thanks so much.
Yeah.
Great, and we have just about 10 minutes left. We have 5 questions currently in the queue. We will make it through those 5, but that's probably all the time we will have for today. If you have any details you need or questions that you aren't going to have a chance to get answered, please go ahead and send us an email. And with that, we'll go to the next question.
And our next question is from Lisa Grossman with Science News. You may go ahead.
Hi, thanks so much for doing this. I have 2 questions. One is, what keeps it from acting like a solar sail? You have this big stretched out thing that's facing the sun. Why doesn't photon pressure from the sun push the telescope off course? And the second is, what happens if there's a coronal mass ejection or a solar storm?
Okay, so
I'm not sure I can answer that one very well. Go ahead,
the Sunshield, you probably have seen it on the very back tip of the Sunshield is something we call it an aft flap, or we've called it in the past momentum flap. That surface area is basically designed to offset the solar pressure of the Sunshield based off the center of gravity of the observatory. And so we're already measuring the momentum accumulation of the deployed Sunshield, and it's doing very well to our model predicts. And that's really what ends up using, the fuel over the lifetime is really just, the momentum will build up over time, will offload, but basically that aft flap and our predicts are well within our lifetime requirements from what we're seeing right now. So that's the purpose of that, if you've seen that in any of the pictures of the observatory.
So it has a rudder.
Yeah, there you go. It's got a rudder.
Exactly right. But we will use the fuel, as Jim was saying, to maintain the orbit in the presence of that solar pressure.
Yeah, now in terms of a coronal ejection, what we did way back in the day is the L2 environment's got really some very unique, radiation environments, and we designed our Sunshield optical properties and tested it once again to show through light, and it was really not so much that, but you get these really low energy, low proton, low electron environments out there, as well as the bulk dose radiation, and we did a lot of very unique testing with the membranes and the optical properties to show how they change versus time, verified that the membrane wouldn't actually charge up and discharge as well, and that that the optical properties wouldn't degrade too quickly. And so there was a lot of early development testing with just the basic coated membranes to show that it would survive that L2 radiation environment.
Yeah, this is James. If I could just add one quick thing, and that is that all that stuff that Jim was just describing was identified as one of the main technology developments that needed to be done for Webb really early on in the design phase. So one of the TRL-6 development, technology readiness level development programs that had to be done really early on was to make sure we had the right materials and coatings for that environment.
Do you remember what year approximately that was?
When was the TRL-6 report? Maybe 2006, 2007?
Wow, okay.
Yeah, to go back and look at, probably have a copy on my computer somewhere.
Yeah, I do too.
Yeah, it was very early on, pre-PDR phase.
All right, we'll go ahead and take the next question.
Our next question is from Marcia Dunn with Associated Press. You may go ahead.
Hi. I'm wondering, when will the near deployment start? It almost sounded like they were going to start kicking into that right now. It wasn't clear to me. Are you really going to press ahead today, or when do you plan to do the near deployments, and how many days do you think it'll all take?
I think the mirror deployment will start immediately after we complete. When you say mirror deployment, there's 2 phases to mirror deployment. Are you talking about the wing, the mirror, the the wing itself or the mirrors, individual mirror segments?
The whole thing.
Okay. Well, all right. Well, we'll start the mirror deployment immediately after we complete the Star Tracker. I think it's a day. We have a no deployment day, so I would say probably by this weekend we will start that process. But then it runs for about 10 days. That whole mirror deployment is a 10-day period. But then after the deployment, then we go into the actual optics for the actually alignment, which is further movement of the mirror. So it's a very lengthy process, but we'll start that probably this weekend.
Thanks.
All right, we can move to the next question.
Our next question comes from Stephen Clark, Space Flight Now. Your line is open.
So, you follow up.
Yeah, thank you, and congratulations, Stephen Clark from Space Flight Now. I think my question is, I just want to confirm, are you sure, based on telemetry, that you all have the proper separation between those 5 layers? Do you have a telemetry signal that indicates that proper spacing between the 5 layers, or is that something you can't really confirm until you monitor how the telescope is cooling down to make sure you do have the right the right separation to radiate that heat back into space? Thanks.
So I'll take that one. This is Hillary. Our spacing is determined by the setting of the mechanism, and the mechanism that performs tensioning is all spring-based. So we have springs that extend to a certain amount, and that extension will tell us how much tension is in the layer and the position of the layer relative to the others, right? So what we're trending on orbit is how long that spring strokes before we see it latch. If you listen to the broadcast, you hear a lot about latch events. And that spring stroke tells us an exact position, which gives us, by geometry, the spacing between the layers. We're very confident in the spacing on the photograph.
Thank you. I will go back very quickly to what Alfonso was saying. I just want to make clear, he was talking about 10 days worth of minor adjustments that keep happening. The actual unfolding, let me toss back to you, is probably a little shorter, right?
Yeah, just to follow that up, we're starting, tonight we'll start heating the motors that deploy the secondary mirror structure, and subsequently following that, in the next 2 days, we'll start heating in preparation for the wing mirror deployments. So the structure itself, the structure deployment that supports the mirror will start earlier. Then after that, then we'll do the deployment, which I mentioned later on this week.
Great, thank you. And then we will go to the next question.
Our next question comes from Ken Kramer with Space Up Close. Your line is open, Ken.
Hi, thank you for doing this and taking my question. And again, congratulations on a great work so far. And my question is about the science instruments. When you can start cooling them? You mentioned that. Commissioning them. You mentioned it's going to take a while to cool. Does the whole structure have to be cooled completely before you start commissioning those science instruments, or does it start at some intermediate temperature? Thank you.
Well, we don't have an instruments specialist in the room, but I can take a shot. This is James, and that once we have done the process that Alfonso was describing a minute ago with secondary mirror support structure, deploying the secondary mirror and the wings deploying, and then they get the mirrors focused, they'll start into commissioning. But I can't answer on a particular instrument how long they have to wait, to start, checking it out. I don't know that level of detail on what temperature each one has to be and how long that'll take. Jim, do you? Yeah, so I think that's the best we can give you in the room right now.
All right, thank you. Maybe you can follow up another time.
Great, Ken, you've got my email. This is Karen Fox. Go ahead and send me a note, and we'll see what we can get for you.
I'll do that. Thank you.
Great. And I think we have one last question.
Yes, our last question comes from Marina Corinne with The Atlantic. Your line is open.
Hi again. Just a question on the timeline. What happens next? Is the team getting a little bit of a break? And when do you anticipate all the deployments to be complete, the ones that you anticipated will be complete no earlier than Friday, January 7th. What is the new time frame on that, given what you've done today?
Well, I think we do have a kind of a rotating shift on our deployments team. So the people who have been super busy with Sunshield will be able to get a bit of a break on a rotating basis. I don't think any of us in the room here are done. We'll all be involved in the rest, some of the future deployments as well. But yes, we're trying to make sure nobody works too many 12-hour shifts in a row. So there will be a break on a rotating basis, and we have different experts for different hardware that'll be stepping in as well. So, and as far as a timeline, I believe the nominal timeline would put us Monday, having the remaining structural deployments done.
Yeah, just to add to that, this is Alfonso. We staff, in terms of deployment support, to support the deployment, at least the spacecraft commissioning phase, which is the first 30 days. So that's what we signed up for. And then it goes into the OTE phase and the mission, and then the optic phase. So. But we're here to support it as long as necessary.
Thank you all so much for joining us today. As I have said a couple of times, this is Karen Fox. Feel free to send an email to me or your other contacts within NASA, as well as Northrop Grumman, who were here today, and we will try to get you any extra details, or if you have a question that we didn't have time to answer, we'll definitely follow up. We are, as you've heard, the mood was really jubilant, but still more to go. So thank you for being here today. And we will be sharing a recording of this as soon as we possibly can. So if that is something you're also looking for, you can send an email. But we'll get that link up on our blog at blogs.nasa.gov/web to these as soon as we can. Thank you so much.